Have you ever wondered what makes roller coasters so thrilling? The answer lies in a fascinating concept called gravitational potential energy. Today, we're going to explore this hidden power that not only makes amusement park rides exciting, but also plays a crucial role in our everyday lives. Gravitational potential energy is the energy an object possesses due to its position in a gravitational field. In simpler terms, it's the energy stored in an object because of its height above the ground. The higher an object is, the more gravitational potential energy it has. To understand this concept better, let's imagine a book sitting on a high shelf. As long as it remains on that shelf, it has gravitational potential energy. If you were to push it off the shelf, that potential energy would be converted into kinetic energy as the book falls to the ground. Now let's apply this concept to something more exciting. Roller coasters. These thrilling rides are masterpieces of engineering that harness the power of gravity to create an unforgettable experience. The key to their operation lies in the clever manipulation of gravitational potential energy. When you're slowly climbing up that first big hill on a roller coaster, the train is gaining gravitational potential energy with every foot of elevation. You might feel a mix of excitement and nervousness as you ascend, knowing that what goes up must come down. That anticipation builds because subconsciously you're aware of the energy being stored. As you reach the peak of that first hill, your train is at its maximum height, which means it has reached its maximum gravitational potential energy. This is the moment of truth, the calm before the storm. Then, as you tip over the edge and begin your descent, that stored potential energy starts to convert into kinetic energy, the energy of motion. The relationship between height and energy in a roller coaster is direct and crucial. The higher the initial hill, the more potential energy is stored, and consequently, the faster and more thrilling the ride can be. Roller coaster designers use this principle to create a variety of experiences, from gentle family rides to heart-pounding thrill machines. But it's not just about that first big drop. Throughout the ride, the coaster's track is designed to continuously convert between potential and kinetic energy. Each hill stores a bit more potential energy, which is then released as you zoom down the other side. This back and forth between potential and kinetic energy is what gives roller coasters their characteristic up and down motion. The concept of gravitational potential energy extends far beyond amusement parks, though. It's a fundamental principle in physics that helps explain many natural phenomena. For instance, water at the top of a waterfall has gravitational potential energy. As it falls, this energy is converted into kinetic energy, creating the powerful rush of water we see at the bottom. In hydroelectric power plants, engineers harness this same principle to generate electricity. Water held behind a dam has enormous gravitational potential energy. When released, this water flows through turbines, converting its potential energy into electrical energy that can power our homes and cities. Even in our daily lives, we interact with gravitational potential energy constantly. When you climb stairs, you're increasing your own gravitational potential energy. When you ski down a slope, you're converting that potential energy into the kinetic energy that propels you forward. Understanding gravitational potential energy can also help us appreciate the marvels of the natural world. The majestic arches of rock formations in national parks, for example, are the result of millions of years of erosion, a process driven in part by the conversion of gravitational potential energy as water and wind wear away at the stone. In the realm of space exploration, gravitational potential energy plays a crucial role. When launching a satellite or spacecraft, enormous amounts of energy are required to overcome Earth's gravity and reach orbit. Once in space, however, objects can use the gravitational fields of planets and moons to gain or lose energy, allowing for complex maneuvers with minimal fuel use. This concept even extends to the largest scales in the universe. The expansion of the cosmos itself can be thought of in terms of gravitational potential energy. As galaxies move further apart, they gain potential energy in each other's gravitational fields, contributing to the ongoing expansion of the universe. Returning to our roller coaster example, we can now appreciate the intricate dance of energy that occurs during a ride. As you're pulled up that first hill, the motor is doing work against gravity, storing energy in the train and its passengers. Then, as you plummet down the other side, that stored energy is released, propelling you through loops, corkscrews, and more hills. The next time you ride a roller coaster, take a moment to appreciate the physics at work. Feel the anticipation build as you climb that first hill, knowing that you're gaining potential energy with every foot. Then, as you crest the peak and begin your descent, revel in the thrilling conversion of that potential energy into motion. In conclusion, gravitational potential energy is a powerful and ubiquitous force in our universe. From the tiniest particles to the grandest cosmic structures, it shapes the world around us in countless ways. Whether you're enjoying a roller coaster ride or simply walking up a flight of stairs, you're experiencing this fundamental principle of physics in action. So the next time you find yourself at the top of a hill or a tall building, remember, you're not just at a high point, you're at a point of high potential energy, ready to be unleashed.